All right, let's talk about a truly radical idea in physics. We're going to explore something called the MMU framework by asking a really simple question, but one with absolutely profound consequences. What if it's right?
I mean, really think about that. This one question could change, well, everything. If the core ideas of the MMU framework are actually correct, it would completely redefine our understanding of reality itself. So let's explore what that even looked like. The first huge change, the first domino to fall, is our entire picture of space-time. Instead of it being this passive, empty stage where things happen, the MMU proposes that space itself is an active, elastic medium that has a definite structure to it.
And if that's true, the change isn't just about some new math. It's about a new ontology. And that's just a fancy way of talking about what fundamentally exists. We're not just redecorating the house of physics here, we're talking about rebuilding it from the foundation up.
So let's start right there with that foundation. What are the new building blocks of reality in this picture?
The core concept at the heart of all this is something called the cell. You can kind of think of it as the pixel of reality, the fundamental atom of space-time itself. It's this tiny geometric unit, a dual tetrahedron, that has specific elastic properties. Now these cells, they don't just float around. They actually link up to form a lattice. And this is the fabric of space. Because it's a structure, it can stretch, it can twist, it can compress, which makes it a very active, structured medium.
This, of course, leads to a critical question. If we've just completely redefined space, what in the world does that do to our concept of time?
And here is where things get really wild. In the MMU, time isn't a fundamental ingredient of the universe. It's what the theory calls a projected observable. Think of it like a shadow on a wall. The shadow is real, you can see it, but it's just a projection of a deeper, three-dimensional reality. I know, formula on the screen, but stick with me. What this is basically showing is that the time we measure t is just a projection. It's the combined effect of three hidden internal motions happening inside your cell. We don't perceive those little wiggles and twists directly, only their combined effect, which we experience as the forward flow of time. An idea like this challenges one of the most fundamental baked-in assumptions in all of science, that time is the ultimate, absolute background of reality.
So, if the Earth cell is the source of space and time, what else can it explain? Well, this is where the really compelling idea of unification comes in.
The theory suggests that the fundamental forces of nature are just different observable faces of the cell's internal dynamics. So a stretching motion gives us what we see as electric behavior. A twisting motion shows up as magnetism and spin. And a change in volume, well, that's the source of gravity and mass.
So, all these different responses, they arise from the Earth cell's basic geometry. The key idea here is that all the complexity we see, every particle, every force, every field, are just different tunes being played on one single underlying instrument, the space-time structure itself.
And what's the grand prize for all this unification? It would mean that quantum mechanics and general relativity, the two pillars of modern physics we've been trying to connect for a century, aren't separate theories that need to be forced together. They'd simply be different descriptions of the very same hidden dynamics of this space-time lattice.
So, if the framework is correct, it has to give us a new way of seeing the world, right? Let's take a look at how it reinterprets what we're already observing out there.
For experimental physics, this is a complete game changer. Our most precise instruments get a new job description. Atomic clocks wouldn't just be measuring time, they'd be directly testing whether time is a projection. And these highly specific measurements, like King plots and the Lamb shift, they'd become our probes, our windows into the very structure of space-time itself.
This new lens also scales all the way up to the entire cosmos. A black hole would no longer be a weird point of infinite density. Instead, it'd be an extreme state of compression of the space-time lattice. And the expansion of the universe? That might just be the lattice itself relaxing from an unbelievably dense initial state.
This brings us to the final, crucial question. Where do we go from here? What are the consequences for technology and for the practice of science itself? Looking way down the road, the technological implications could be huge. We could maybe develop new kinds of sensors designed to literally read the internal state of spacetime. This could kick off a whole new era of metrology, the science of measurement, based on the fundamental structure of reality itself.
And this is probably the most important consequence of all, the MMU is a scientific framework, not some belief system. It doesn't matter how elegant or compelling the idea is. If its predictions do not hold up against precise experimental tests, it has to be rejected. That's the discipline that science absolutely demands.
So, you see, the true value of a theory like this isn't that it's asking you to believe in it. Not at all. It's that it generates a whole new set of sharp, falsifiable questions that can drive real research forward. Is time truly projected? Can we measure the different response channels of space? That's where the real excitement is. So let's just recap the whole transformation. If the MMU is right, space becomes an active structure. Time becomes an emergent projection. Matter becomes a stable excitation of that structure. And as a result, physics would take a giant leap closer to a single, unified ontology.
This image of the dual tetrahedral your cell, it really captures that entire vision, doesn't it? The idea that this one fundamental geometric unit could be the source of everything we see. From quantum mechanics all the way to gravity, that's the essence of the search for a unified theory.
And that is the ultimate promise of the MMU. It's not just offering another model with a few new equations. It's proposing a profoundly new way of understanding what reality itself is actually made of, a testable vision that could redefine the very fabric of the cosmos.